This is the second lecture on isotopes and ions. Remember, the first went over extensively about ions and also gave a brief overview about isotopes. So this one is going to focus on isotopes. So just a reminder, isotopes are atoms of the same element that have different numbers of neutrons. So up to this point, we've really only looked at protons and electrons. So now we're going to start looking at how many neutrons an atom has. So atoms of the same element with different numbers of neutrons. So an example of this would be, I could have a carbon atom that has 6 neutrons, and I can have another carbon atom that has 8 neutrons. Same element because they're both carbon, but they have different numbers of neutrons. Okay? So before we even begin solving any problems, the first thing to recognize is isotope notation. So different ways that we can write out the isotope. So this number up here is our superscript. This is our element symbol. And this is our subscript. So now we need to see what each of these numbers mean. So the superscript is going to represent the mass, the atomic mass. The subscript is the atomic number. And then obviously the element symbol is representing what element we are discussing. So when we're looking to solve for isotopes, you're also going to want to look for how many protons and electrons there are as well. So now, up to this point, we've only been solving for the protons and electrons. And now you will be able to solve for all three. So we know just from what we've done already that our proton number comes from our atomic number, which is 6. The electron number, if it is neutral, also is going to be equal to your protons. And if you look here, there is no charge after that carbon, meaning it is neutral. So we're going to have 6 electrons as well. And now to find the neutrons. So the mass of any atom is going to come from the nucleus. Now if you recall what two things are in the nucleus, it's your protons and your neutrons. So if we add up our protons and we add it to our neutrons, that is going to give us the atomic mass or the mass of that atom. So our mass is 12. So we have 12 equals, protons we know we have 6, and we're adding that to the N. So just do some algebra there and you're going to get that your neutrons equals 6. So this isotope of carbon has 6 protons, 6 electrons, and 6 neutrons. So here's another example with the 13 up there at the top. So this is carbon with an atomic mass of 13. Atomic number obviously going to stay the same because it is carbon. So we're going to solve again for protons, electrons, and neutrons. Protons still coming from that atomic number, which, if you recall, is going to be your subscript. It has no charge here, so our electrons are going to be the same as our protons. And now, remember that mass equals your protons plus your neutrons. So I got that mass number up here from this 13. So rearranging this, doing some algebra, we see that neutrons equals 7. So this is another isotope of carbon. Looking at the first example that we saw, that one had 6 neutrons, and this one is the same element. It's carbon, but it has 7 neutrons, meaning they are isotopes because they are the atoms of the same element that have different numbers of neutrons. So now we'll look at this one down here with the hydrogen. We have an atomic mass of 1. We have an atomic number of 1. Protons, electrons, neutrons. protons, we're going to have 1. That's coming from this atomic number. No charge on this, so we're going to have the same number of electrons. 1 equals, that's our atomic mass right here, equals our number of protons plus our number of neutrons. Solve for that, we're going to get n equals 0. Is that okay? Yes. You can have 0 neutrons in an element. So do not be alarmed if you get an answer like n equals 0 with this. It is okay. Just remember that your mass comes from the protons plus the neutrons. And if that's what you get, then that is correct. Here are 2 more examples for you. I want you to get these written down, pause it, and try them on your own, and then you can come back and we will see how you did. Okay, so hopefully you've tried these. We're going to take a look at them. Remember that this bottom number is your atomic number. That's going to tell you your number of protons, so that's where I got the 92 protons. No charge on this, which means that it's neutral, so we have equal numbers of protons and electrons. So that's where the 92 came from. 238 is your atomic mass. So we have 238 equals 92 plus your neutrons. Solving for n should get you 146. Up to this point, we have seen our protons and our neutron numbers be very similar or very close in number. And these are not close at all. That is okay. Do not think that, oh, why don't I have 95, 94 neutrons? Do not associate those numbers with being the same. You can have a lot more neutrons than you do protons because both are contributing to that mass. They do not have to be equal in charge because remember that neutron is 0, so it's not contributing any charge to your overall atom. Looking at the nitrogen down here, proton number came from our atomic number. There is no charge, so these are equal. 15 equals 7 plus n equals 8. So really this is just doing some algebra here, subtracting 92 from each side, subtracting 7 from each side. That's going to give you that neutron number. This is another way that we could write an isotope. So you're looking at uranium-238. This 238 right here is another way for us to write the mass number, or the atomic mass. So 14, that's also your mass number. So that's the same thing as us writing the U with the 238 or the carbon with the 14 up here. It's just a different way of writing it, so make sure that you are able to recognize that as well. The only thing that this version right here that we're looking at does not show you is your atomic number, but if you know the element, you can find the atomic number through the periodic table. So know that that periodic table will be available for you. So just remember that that is somewhere that you can find that information as well. So now that we have looked at isotopes and ions, I want to show you an example that includes both. So we've seen the notation on this side today on this lecture. We've seen the notation on this side with the previous lecture from the ions. So now we're going to combine it all together because this is a more realistic look of what you're going to see. So we are looking for protons, we're looking for electrons, and we are looking for neutrons. Proton number, always start with that. That's the easiest one to get out of the way. It's never going to change. So our proton number comes from our atomic number, which is down here. So it's 8 for oxygen. Now we could go either electrons or neutrons. Remember there's a charge here, which means that we have a different number of electrons than we do protons. Since it is negative, it means that we have more electrons than we do protons. How many more? It tells you right in the problem. It tells us we have 2 more. So 2 more electrons than protons means I'm going to have 10 electrons. And now we just need to solve for our neutrons. So remember that our mass number came from the 17, which is right here. Our mass equals our protons, which is 8, plus your neutrons. So now we're going to have 9 neutrons in this version of, or this form of oxygen. So this form of oxygen is not neutral because it has a charge from the varying electrons to protons. And then it has 9 neutrons, which another version of oxygen could have 8. Another version of oxygen could have 7. So make sure that you are able to do both this side right here and you're able to do this side right here and apply them to the same answer. Okay, so that is the end of this lecture. Go ahead and work on some practice problems. Let me know if you have any problems.